the new norm. Okay, so this is the first problem on this week's homework. It says, for this question, please draw the Lewis structure of CH2O. If you successfully draw it, then type yes into the box. Typing yes into the box will award you the points for this question. You are on your honor to complete this question. If you cannot successfully draw the Lewis structure, please see me or rewatch the lecture outline videos. Now, as far as drawing Lewis structures, that is the main goal today, so we'll be drawing a lot of them. We have a couple other goals too. But instead of doing your homework, I'm going to do a similar example. I'm going to do SO3. And since this is our first Lewis structure, I will go through the entire process. In fact, I'll probably go through the entire process for all of the homework today. And what I will say is the Lewis structures are the basis for about the next 3 or 4 weeks of lecture material. So if you can't do Lewis structures, you will struggle with the rest of the material. Okay, well, so if you saw the lecture videos, which I know you did, then you know that there are steps to making a Lewis structure. And a Lewis structure, just to say this for the first time, a Lewis structure shows all atoms, all bonds, and all electron pairs. All atoms, all bonds, and all electron pairs. And that's my, looks like it froze right now. Come on, catch up. That's my definition of a Lewis structure, and it will usually say that, certainly on exams. So Lewis structures, all atoms, all bonds, all electrons. Electrons are usually the only thing that people forget. Okay, so in order to do a Lewis structure, you count up the number of valence electrons in the molecule. Valence electrons are electrons in the outer shell, and you can look at your periodic table and figure them out. For example, sulfur and oxygen. So sulfur and oxygen are in group 16, and this 6 number is the number of valence electrons per atom. Sulfur has 6 valence electrons. Oxygen has 6 valence electrons per atom. And we will be counting up the total number. So for SO3, sulfur has 6, plus oxygen has 6, and there are 3 oxygens, so 3 times 6. I get 18 plus 6, that's 24 valence electrons. And those are going to be the electrons that we put into the Lewis structure. Core electrons do not participate in bonding, and so they will not appear in Lewis structures. Excuse me. Okay. Step 2 is to put the least electronegative atom in the center. If you'll remember your trend in electronegativity from the lecture outlines, electronegativity decreases as you go to the left, and electronegativity decreases as you go down. So electronegativity decreases from oxygen to sulfur. Sulfur will be our central atom. And then we will surround it by oxygens. And if there's more than one central atom, I will tell you, or if there's any question as to what the central atom is, I will tell you, and if I make a mistake, please ask. I think the only thing where I don't tell you the central atom is when there's carbons and hydrogens, and that's because hydrogen cannot be a central atom, and carbon usually is. Okay, so step 2 is to draw the sulfur in the center. Step 3 is to connect the atoms by single bonds. So each single bond represents 2 valence electrons. So let's see, this bond equals 2 valence electrons. And so far I have 6 valence electrons in my Lewis structure. From there, the way I put it is that you sprinkle the rest of the valence electrons around until you get to 24 by completing octets on outside atoms first. That's going to be, so, and I'm going to count them up. Let's see, 2, 4, 6, 8, 10, 12. That's 12 total, and this oxygen has an octet of valence electrons. 2, 4, 6, 8. Then let's recount 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24. So I have 24 valence electrons. I cannot put any more in there. Are there any questions so far? I know I'm not done, but that's where we are so far. Okay. Well, you can see that the central sulfur atom does not have an octet. If I look at the sulfur, it has 2, 4, 6 electrons around it. Sulfur follows the octet rule, although we'll talk about that too. But our next step is going to be to take 2 electrons from any one of the oxygens and form a double bond. That means that there are 2 dashes, and you don't have to do this, but I like to do it. So the electrons moved, and I removed them and put them between. I don't really count that. Like, you don't have to be super careful about that, but it helps me understand the process, so I do it like that. Okay, so there is our next step. Now, every single atom has 8 valence electrons, and from that standpoint, that's a good start on the Lewis structure. Now, for every single Lewis structure that we will do, we will then evaluate formal charge. And we might as well start from our first example here. And this formal charge is going to be, the formula equals number of valence electrons from the periodic table minus, and I'm going to run out of space here. Hold on. As my soccer coach always used to say, learn to create space and run to the space. So that's what I'm going to do. Minus, to complete this formula, minus number of bonds plus, and this is a quantity, so these two things are added together and then subtracted. Number of bonds plus number of unshared electrons. Got to create more space, I guess. There we go. Number of unshared electrons. And so if I evaluate the formal charge on this oxygen here, which I'll call oxygen A, then what that looks like is that the formal charge is going to be, well, number of valence electrons from the periodic table, that's 6, minus number of bonds, well, it has 1 bond, and the number of unshared electrons are 1, 2, 3, 4, 5, 6. So 6 minus 7 is minus 1. So this oxygen currently has a formal charge of minus 1. The way that we represent that is we put a minus with a circle around it. And I put it down here. You could put it anywhere such that it is clearly associated with this oxygen. And see this oxygen over here? It has the same pattern, meaning single bond and 1, 2, 3, 4, 5, 6. So it will have the same formal charge. Any questions right now? All right, let's keep everything moving together there. So next we are going to do formal charge on this oxygen. So let's see. Now let's do that over here. Formal charge on this oxygen is going to be number of valence electrons from periodic table. That's the same, that's 6. Now I have 2 bonds plus 1, 2, 3, 4 unshared electrons. The formal charge on this oxygen is 0. Now let's do the formal charge on sulfur. So, and I guess I should say, yeah, so that's for this oxygen, and these are for these oxygens. Formal charge on sulfur. Sulfur also has 6 valence electrons from the periodic table. This sulfur has 1, 2, 3, 4 bonds plus 0 unshared electrons. That's going to be a 2, or what is usually referred to as a plus 2. And you go ahead and put that in a circle too. So those are the formal charges. And I would suggest to you that those have to be the formal charges, or as soon as you find 2 separate minus charges and you see that this molecule has 0 overall charge, you must then find 2 plus charges somewhere. And so far they're right here on sulfur. Overall, the formal charges will equal the charge on the molecule. So sum of formal charges equals charge on molecule. And we'll see ions, so molecule or ion. Okay. Now, we're not done yet, but the next thing we need to do is we need to then minimize formal charge. And I'm going to use the abbreviation for formal charge, FC. FC also reminds me of soccer or football, as it is lots of FC football clubs in Europe. Anyway, we're going to minimize formal charge. What that means is that if I see a minus and a plus, I will try and get rid of it. It turns out that sulfur can have an expanded octet. Meaning that I can form a double bond here and a double bond here. When you form a double bond between an atom with a negative formal charge and a positive formal charge, you will then see, and I'll draw my answer finally down here at the bottom. You can go back and show that each of the atoms in this final answer has 0 formal charge. When we minimize formal charge, all of the atoms having 0 formal charge is the minimum. You can't get any less than zeros everywhere. And so this is our final answer. And what we've gone over for this particular one is we've gone over how to do a Lewis structure, then how to do a formal charge analysis, then how to minimize the formal charge using expanded octets.